the video. They'll be sharing the technical challenges. They'll be looking at the design trade-offs, the key learnings that they get from integrating multiple AI-powered cloud services. Plus, they'll offer a glimpse into what's next for real-time intelligent experiences. So, chaps, would you mind coming up on stage? Get ready to deep dive into a future of AI-powered interaction. Please give Will and Dallin a round of applause.
Thank you.
Thank you.
Hello. Hello. Is the mic on? It is. Great. Okie dokie. That's good. Hello. I'm Will Hamill, and this is Dallin McGuckian, and we want to talk about something that we've been building over the last couple of months. We showed off at AICon. We've been evolving ever since. We want to give you a bit of a sense of what the kind of difficulty is of building it, which isn't really very difficult, to be honest, if I'm involved. And what we built, what we learned from it, and basically where do we see it going next, and a little bit about how you can do something similar. So what we wanted to do, and we'll show you a demo in just a second, was create a kind of a digital panelist. So an AI avatar that can contribute to conversations or discussions, just like somebody joining a Zoom or a Teams call. We wanted to have something that would be as close to real-time speech in and out as possible, so that it could have a meaningful conversation without waiting a minute between responses. And we wanted it to be relevant and safe and on topic and useful and helpful. So those were all the kind of aims that we had going into it. So hopefully we can start this video. You can see a little bit of...
Hey everyone, I'm excited to present the latest version of our digital panelist, Clio, with some of the new features we have added. Firstly, you can see Clio's listening mode in action. Notice how it remains in listening mode until directly engaged. This is obviously a feature that's crucial for realistic and human-like interactions. Hey Clio, please introduce yourself.
Hello, I'm Clio, a digital avatar developed by Kainos. My role is to provide information and answer questions about AI and IT-related topics. I was first introduced at AICon 2024 in Belfast and have been continuously evolving since.
Can you provide an example of how you could be used in a commercial setting that's not customer service?
Certainly. In a commercial setting, I could be used for employee training and development. For instance, I can assist in educating staff on new software tools or IT systems, providing on-demand explanations, troubleshooting common issues, or guiding through complex processes. This would help in reducing downtime and improving the overall efficiency of the workforce.
This highlights how Clio can seamlessly answer questions, but also enter and exit conversations easily. If no further questions are asked, Clio returns to your listening mode and ready for the next interaction. So to demonstrate RAG, or Retrieval Augmented Generation, Clio can pull the latest internal data, ensuring that she provides information that's both current, specific, and trusted, as the documents have been selected and curated by the team. So moving on, Clio, please tell us about how Kainos assisted a UK investment company using internal insights.
Kainos assisted a leading UK investment company, specifically an asset management firm, by implementing Azure OpenAI to empower their equity analysts. The company wanted to improve the efficiency of examining over 3 zero stocks each year, which previously took around 3 to 4 weeks per stock. By integrating Azure OpenAI into their existing equity research system, Kainos developed an AI self-service tool. This enabled the team to analyze more stocks and delve deeper into their analyses. Overall, this initiative allowed the business to scale and provided a foundational AI platform for future capabilities. This tool helped the analysts to work more efficiently by reducing the time taken to analyze stocks by 30%.
Great. And finally, let's kind of show how Clio handles interruptions. So simulating that of a dynamic human conversation. Hey Clio, what does LLM stand for?
LLM stands for Large Language Model.
Okay, that's enough.
These models... I understand. I'll stop now.
Hopefully you're a bit nicer than I was to Clio there. But
You're going to be on the list when they take over. Yeah, hopefully useful demo. We clearly dropped a bit of sales material into the RAG content there. Yeah, go ahead.
Hey everyone.
Oh gosh, there we go.
That's it. This is an example of what it looked like before. So that's when we were having it kind of join the panel discussion at AICon. So it's come on a little bit since then. And here's a bit of a view of the original actual architecture, not the intended architecture, because that's always a little bit different. Fundamentally, this thing was built at the initial stage with speech-to-text, large language model inference for answering questions, and then text-to-speech and text-to-video on the way out. We had kind of text-to-speech as our backup plan, and then realized we didn't need to use it whenever the text-to-video was good enough. This is built in Azure using Azure Functions, talks to the Azure hosted version of OpenAI, and records the transcript anytime it's listening to a question, appends what it's been saying and what the question is every time a question's been asked, and then adds that into the conversation whenever it's asked to generate a new answer. So that's what we kind of initially put together, but there were a few kind of speed bumps along the way to try and get it to be a little bit responsive. So, I mean, if you've seen mobile phone ads on TV, you'll see sequence shortened. We haven't shortened the sequences for this. There's only a couple of seconds delay, but how to get down to that was a bit difficult, so we had to make a couple of different compromises along the way. Dallin, do you want to tell us about that?
Yeah, so a key design decision that we were actually trying to make was in speech-to-text. And in our earlier versions, we actually experienced quite slow delays, and that was because from the front end, we actually created our own audio recorder, and this audio file was then sent to an audio processing function, which would save to the audio file to blob storage, which would then trigger another speech-to-text function that would then actually call the Azure speech-to-text service, transcribe the audio into text, then actually save this transcript to a blob storage text file. And then in the event of a question, this question was then passed to an LLM function, which would then retrieve the transcript, pass this to a 4.0 model to generate a response, and then pass it down to later functions for video and things like that. The latency in this was between 5 and 7 seconds. And that was basically because we were using file transcription with Azure Search. But on top of that, it was very synchronous, so we actually could even ask a question until the transcript had appended. So we obviously needed a faster approach, which was closer to real time, as well as more asynchronous. So we landed on this, where we actually were able to use a speech SDK in the front end, which would asynchronously call the Azure AI speech-to-text service directly. This then transcribed text would be passed to the STT function and then asynchronously append to the transcript. And in the event of a question, the question was then passed to the LLM function, which would then retrieve the transcript, pass it to the 4.0 model, and generate the response. This reduced our latency considerably and also used less functions, so it was reduced complexity.
Thank you. And so that was one of the things that we really wanted to improve on and keep improving. And in terms of the interactivity as well, lower time to first response. We wanted voice-initiated commands instead of having to press a button to tell the difference between answering a question and listening to the question. And we wanted to make sure that we could really add that domain-specific or private knowledge that isn't already baked into the model. We also wanted to improve application security so that instead of having to trust the client, we could use an untrusted client so that we could use it in lots more different scenarios, and we have a kind of an easier approach to being able to scale that out to different use cases. So that's what we were looking for with the V2 improvements. So Dallin, do you want to tell us a little bit about that?
Yeah, and so some changes between the version 1 and version 2 was we actually moved towards a back-end driven architecture rather than front-end heavy. We used different communication. So in the first example I showed there, we used REST APIs to manage things such as front-end, back-end communication and state. However, we actually used WebSockets, which was a lot faster. We wanted to move away from a button functionality to a voice-initiated commands, and we were able to do this with GPT 4.0 voice mode. We wanted, as previously described there, add some dynamic retrieval of internal curated documentation instead of passing this in through the prompt. We invoked the video stream in a different way, so we actually used the WebSockets to stream the response from the LLM to the front end, and then we actually queued this stream and passed this on to HeyGen for the video. We again improved security, moving towards managed identities and storing the API keys in the back end, which meant we didn't have to trust the client as much, which is obviously more scalable for security and access control. And pardon me, we moved towards actually using containers over functions, and that was just really for the time to first response. Functions can be cold, however, obviously having a container, it's already on standby.
Yeah. So the new architecture looks more like this. What we've got instead of speech-to-text, large language model, and the text-to-speech or text-to-video, is we actually use the real-time audio mode in GPT-4o and just do the audio streaming straight into the model for inference. So it cuts out an extra step, which reduces latency, and it's really good quality audio transcription as well, which is good. That returns us both an audio response, if we want it, and the transcript. We don't use the audio response for that. We actually send the response in the transcript to HeyGen to get the video. And as Dan said, we stream the video back after sending chunks of text instead of sending the whole answer, so we can get a faster time to first response. We integrated RAG, so retrieval augmented generation, to basically pull out the documents that we wanted to add to it that we knew weren't in the original training data set. And we've basically kind of put that together in an app service for Docker so that we could take advantage of kind of warming it up in advance instead of having to worry about the cold starts for the functions in this particular scenario. Dan?
Yeah, so really an issue that we were having was defining interactions. So like humans, obviously, we hopefully listen during conversation, and this can help. We also needed to build up the context of what's being said. And then we also needed a speaking mode, so when you actually respond to, say, a question. Now, the issue with GPT-4o voice mode, if you've ever used it, is it always responds, and it can't distinguish when it shouldn't or should respond, sorry.
If you say, like, please don't respond when I tell you this, it'll say, okay, no problem, I won't respond.
Yeah, and so the key challenges was when not to and when to respond. And so this is where we used a bit of prompt engineering and programmatic changes. So in the prompt, we defined two different modes, a listening mode and a question mode. And if there was no question, no trigger words such as, hey, Cleo, basically the LLM would respond with, say, a null value. And then that meant that we didn't actually call HeyGen to get the video output. However, in the event of a question, so a trigger word, hey, Cleo, or any follow-up questions after that, that would then generate a not null response, which allowed us to call HeyGen, create the video, and have the speech. And some key wins of that, we did achieve near real-time human-like conversation. We were able to demo this AICon and BBC Radio, and obviously here today.
Yeah, and so this was really good as both the learning experience for us and as a test of the maturity of the technology that we're integrating here. Our team wasn't loads of AI engineers, data scientists, and like model training. We have those experts to draw on to make sure we're doing things safely. But this for us was really around how do we design that? How do we do the systems integration? How do we try and focus on streaming the asynchronous parts? And using all of these services that were available on the Azure OpenAI side, pay-as-you-go APIs. We didn't have to commit upfront. We didn't have to train stuff. We didn't have to buy GPUs, thankfully. And we also found that the quality of some of these services has really improved, especially over the last year. Like anyone from here will know that regional accents are a bit hit and miss when you get to speech to text. They're really, really good in this GPT-4o voice mode, so I'd really recommend trying that out. We also found it was quite volatile, though, over the last couple of months. A lot of these APIs have changed as new features come out, as people iterate the services. The HeyGen API that we use for text to video has changed for the better, which is great. We've got better quality avatars with lower latency. We have a text-to-speech avatar that was released by Microsoft as well, just so that to throw another spanner in the works and make sure we have to evaluate our options. The real-time audio mode actually was released the day before we had the first demo. So we've reworked that quite a lot to integrate the new audio mode. And some of the interesting parts as well, slower region availability. When they stand up and they announce it at the keynote speech in the conference in America, it's available in America. It's not available in the UK or EU for a while. So that can take a little time to roll out. And it was also a bit tricky at times to make sure it stayed on target, trying to balance the RAG content, so whether or not it knows something from the knowledge base and decides to go out and search that versus whether or not it knows it in the model, and trying to make sure that it didn't say, for example, I can't answer that question if it thinks it's off topic, even if there's content in the knowledge base that we used for RAG.
Yes, and final slide. So really with things we learned as well was with POCs like this, you really need to design together. So creating workshops, that's basically so everybody's up to date with changes, but also to add their inputs when they're boots on the ground and can see obvious issues with, say, latency. Don't be precious with your code, so just drop things that aren't working as fast as possible. And then obviously decouple components such as, using like containers and things. It makes for easier testing and adding further features. But yeah, that's basically us. So.
I think it's us. We're happy to chat about any of this at the break at lunchtime, so please come and hassle Dallin. I don't do any difficult questions, all difficult questions to him, please. Thank you.
Thanks.